Hello students, as I discussed the nucleophilic substitution reactions in my previous video. So today I will sum up all the nucleophilic substitution reactions. So for that, first I will start with the single substrate, and for that we use a single substrate or single compound haloalkanes as CS3 CH2Br. So this is the starting substrate, means we use bromo ethane or ethyl bromide as the starting substrate. When this compound is treated with different reagent, it gives different nucleophilic substitution reactions. So the very first nucleophilic substitution reaction is the reaction of haloalkane with this reagent, that is NaOH, sodium hydroxide, that is in aqueous medium. So this is the substitution by hydroxyl group or hydroxy group, and this is the formation of alcohol. So this is the most convenient way of writing all the substitution reaction as a whole. So NaBr is the byproduct form here, and OH is introduced on the carbon part and it forms alcohol. Similarly, we use other reagents also. NaOH, instead of using NaOH, we use KOH, potassium hydroxide, but keep in mind this, the medium is in aqueous form, or we use AgOH. So for the conversion of haloalkane to alcohol, we use these reagents NaOH, aqueous medium, KOH and AgOH, and it forms the same compound or the similar compound, that is alcohol. So alcohol are formed by haloalkane in this way, and if we use KOH, then byproduct is KBr, and if we use AgOH, it forms AgBr. So simply we write for KOH only here. Now the next substitution is by cyano group, substitution by cyano group and formation of cyanides. For that we use alcoholic medium of potassium cyanide. In this, KBr is out from this reaction, means byproduct is formed, and Cn is introduced on the carbon side and it forms CS3 CH2Cn. So this is the another nucleophilic substitution reaction of haloalkane, formation of cyanides with the elimination of KBr, potassium bromide. इसमें आपका out होगा. The next reaction is when it reacts with AgCN. So as I discussed this reaction in previous video, when KCN reacts with CS3CH2Br, it forms cyanide, and when AgCN, instead of using KCN, if we use silver cyanide, it forms isocyanide. So this is the important reaction here. KCN forms cyanide, AgCN form isocyanide NC, and the elimination is similar, that is salt of silver. AgBr is out from this. Then if we talk about the next substitution reaction, that is if halides or any haloalkane is react with KNO2, potassium nitrite, then it forms CS3 CH2 and ONO. It forms nitrite group with the elimination of KBr, potassium bromide is out from this. And if we use AgNO2, silver nitrate NO2, it forms CS3 CH2 and O2. Here in this, nitroalkanes are formed with the elimination of AgBr. So if we see all these reactions, then the byproducts are in the form of salts and the major product are formed. This is only possible due to the substitution reaction, nucleophilic substitution reaction. This nucleophile attacks on carbon atom and forms different compounds. Similarly, if we see the substitution by amino group, then we use ammonia here, NH3. If we use ammonia, NH3, then one hydrogen from this and one Br is out from this. HBr is out from this reaction as byproduct, and this is the formation of a new functional group, that is amines. Amines are formed in this way. So these are some common nucleophilic substitution reactions. Now the next substitution reactions are, first reaction is of C2H5ONA alkoxide group with haloalkane, and it forms ether. The functional group form here is C2H5O, with the elimination of Na and Br, and this is a specific method for the preparation of ether, and it is known as Williamson's synthesis. And this group is alkoxide group. So, and this group is derived from alcohol C2H5OH. Instead of OH, it is ONA. Then similarly, the next method is when haloalkane, this bromoethane is treated with CS3COOAg, that is known as silver salt of carboxylic acid. So CS3COOAg, here in this AgBr is out as a byproduct, and CS3COO C2H5 is formed. So this is another functional group that is known as esters. These are known as esters. So these are esters, and this group is ether. So new functional groups are formed in this way, and this is another reaction, and the group form here is also a new functional group when it is treated with haloalkane is treated with Na, sodium salt of thioalcohol, SH. S is introduced here. S is thio group in organic chemistry, and NaBr is out from this. It forms CS3CH2SH. CS3CH2 is ethyl part, and instead of OH, OH is alcohol, but here we use S. S is thio, so it is forming thioalcohol. So the name of this compound is ethyl thiol or ethane thiol plus NaBr. And similarly, the next group is this functional group is thiol, and this functional next is when it reacts with haloalkane is react with NaSr. This is very similar to ether. In case of ether, ROR dash is the formula here, RSR dash. Instead of O linkage, here S linkage is present. So the product form here is thioether. So the compound name is thioether. So this is also a new functional group, thioether. And finally, the last reaction of this nucleophilic substitution part is when haloalkane is treated with this is another reagent, and this reagent is derived from alkynes. This is sodium salt because Na is positive here and the whole part is negative. So this is sodium salt of alkynes. Alkynes are triple bonded. So when alkynes are treated with this, higher member of alkynes are formed. So this is one of the important reaction for direct conversions. So in this reaction, CS3CH2 is treated with CH triple bond CNA, and it forms CS3CH C triple bond. So it forms butane. So when ethyl part is treated with this reagent, it forms higher member of alkyne. So this is all about the nucleophilic substitution reactions and new functional groups. So here I have written all the reactions as a whole, including all the nucleophilic types. OH is introduced in this way, KCN, AgCN, KNO2, AgNO2. So this is the overall reaction chart, and this is the best possible way to learn all the reactions with ease. So this is all about the nucleophilic substitution reaction of haloalkanes, and that's why this haloalkane is considered as the synthetic tool for the formation of different functional group in organic chemistry. So this is all about this topic. Thank you.